Okay, record on Mr. Neighbor. All right, welcome to H period number 2. It's Tuesday, May 12th. All right, it's down to day 3 classes to go. Okay, so let's finish strong. All right, here's the plan. In a few moments, I'm going to share my screen with you. I'm going to put up 6-5 problem set 2, which is what we were working on last Thursday. I think we did like 1 through 5 basically, and you had to do 7 through 12. So you only had about 7 problems to do. All right. And then you were supposed to load it on the under the Dropbox, which only about 7 or 8 of you did. I'm going to put the answer key up. My writing's a little sketchy. Okay. Just email it to me, Mr. Bunch. I can't do that right now. And we'll go.
Sir, I think I already turned.
And then I'm going to, actually, yeah, Mr. Bunch, you already did yours. I'm going to put up problem set 6-3, and we're going to collectively shared screen, whiteboard, work through those to work out any of the kinks. And I've already posted, if you looked at Blackboard in the last hour or so, I already posted the quiz for 6-5, and you need to take that by Thursday morning. All right, I think it's like 12 or 13 problems, I believe, and 1 or 2 bonus questions. Unlike the Dropbox for the problem set, if you haven't taken it Tuesday or Thursday before class, then I'm going to shut that one down. And if you haven't taken it, it'll just be a 0. And hopefully it's your only and lowest grade, and that will drop for the quarter. I'm not going to take late deals on this particular quiz. So that's the plan. Any questions or comments before we get rolling?
When did you say that quiz was?
It's already, it should be already in there. I put it in there by now.
Oh, it's the old one. Okay. I thought you said another one.
All right, so here we go. Let's see here. Hopefully this will come through. All right. We did 1 and 2 in class, so we don't even need to look at those. And then I think I did 3 and 5 where I had the blue checks. My handwriting's a little sketchy at best. Sometimes some of it kind of looks like some of your guys' handwriting. So take a look. Let's see at 4 and 6. And I'll just make a couple comments. Check my answers versus your answers. Pay attention. Here we're doing cube roots, all right? And so we're looking for perfect cubes to get out of here. For these problem sets as well as the quiz, hopefully you still got that little 4x4, 5x5, nice little cheat sheet that's got perfect squares and perfect cubes and perfect spurts and cube roots to use as a reference. 81 can be broken down to 27 times 3, and 27 we know is a perfect cube for 3. So it came out from under the radical as a 3. Likewise, 24 is 8 times 3. We love 8 as a cube root because 8 is 2 cubed. So the 8 comes out from the radical as a 2, right? And pay attention, we're multiplying these. So we simplified them first. I believe if you could actually multiply 81 times 24 and do that way, but then you've got huge, large numbers you got to kind of navigate your way through, and this keeps the numbers small. So 3 times 2 is 6, and 3 times 3 is 9, and that 9 stays under the radical, right? Why? Because that's 3 squared, it's not 3 cubed. Any questions on 4? All right, on 5, you had to distribute that 2 radical 3 to both of these guys. And again, you could have either simplified the 15 and, let's see, 15, can we simplify that? So we didn't simplify that. So 2 radical 3 times 15 is 2 radical 45, and then times the 60 is 2 radical 180. And then I simplified the 45 because that's 45 is 9 times 5, right? 9 times 5, 9 is a perfect square, so it comes out as 3. 3 times 2 becomes the 6 there, leaving 5 under the radical. And then 60, you kind of see my little work here, times the 3 was 180, And I was trying to find to see if it had a perfect, if it was divisible by 5, which we know it is because it ends in 0 or 5. All those are divisible by 5. And it's divisible, 5 into 180 is 36, which works out great because the 36, the square root of 36 is 6, right? So the 6 times the 2 becomes 12, leaving 5 under the radical. Now I've got what they call like terms, which is on the, is that on the front of this page? Yes. Or like radical expressions, which means I've got the same value under the radical, and I can add the 6 and 2 for 12. And there's my final answer, 18 radical 5. Any questions on that? Make sense? Hearing none, we'll keep on trucking. Let's see. I'm just kind of going over the high points and things to factor or consider. Number 7, we foiled, right? You had to foil number 7. Let's see if I can move this out of the way. There we go. You foiled number 7, right? Just take a look at it. Let's see if I need to point out anything. Remember, typically with your FOIL, the O and I are like terms. So we combine the 2 radical 7 and the 12 radical 7 for, did I make a mistake there? What's going on there? 8 and 21 is, that's that. 2 plus 12. No, 14 radical 7. Yeah, okay. Your O and your I are typically like terms, so you can combine those. All right, number 8 was also a FOIL. All right. Got a little unwieldy. All right. And then you ended up with like terms here. Oh, I think there was an error here because there was 6 and negative 12. I think this should have been, there was an error there. Yeah, this should be negative 6 right here. Negative 6. Sorry for the overwrite because we got a positive 6 and a negative 12. All right. This negative 4 radical 4, the 4 came out front of the radical is 2, so that became negative 8. And then we had the like terms 54 and minus 8. So 54 minus 8 becomes 56. And this should be 6. Is that right? Let me just double check. Let me just, that doesn't look right. Let me just, give me 1 second to double check that one. Let's see. Yeah, it's 6. That is 6. Okay. Any questions on 7 and 8? I got a lot of scribble there. Are we getting these answers? I hope.
Yeah.
Okay, good. All right, last 4. Number 9 was a FOIL. Take a look at that. We didn't combine like terms, but the only thing we could kind of simplify was we had 100 of the radical comes out as a 10, and we multiply that times the negative 6 for negative 60. It was kind of an unwieldy answer, somewhat long and lengthy. Let's see. Yeah. Well, this we had 40 under the radical, which is 4 times 10, right? So the 4 came out as a 2, multiplied times the 8 gave me the 16, leaving 10 under the radical. This we didn't change any from the problem. We didn't change that one any. All right, number 10. Remember, if you see this in the problem on the quiz, you can't have it radical and the denominator as a final answer. So this is that conjugates thing that's explained on the front of problem set number 1 of this section that hopefully you got there available to you. So we actually multiplied both sides of the equation by 5 radical, or both the numerator and denominator by 5 radical 3. Let's see here. Let me see what I did here. Yeah. I don't know if you see what happened, but we took these and simplified these first, all right? So that be 5 radical 48 became 5 radical under the radical 16 and 3. So the 16 came out as 4. So that became 20, all right? And the 75 is 25 times 3, so the 25 came out as 5 radical 3. So we took those two terms, added them together because they are like terms or like radical expressions to become 25 radical 3. All right. And then again, we couldn't have that 5 radical 3 in the denominator, so we multiplied it in the denominator by 5 radical 3. You can kind of see the math. Oops. I don't know if that's in the web of yours. It wasn't. So your final answer should be 5 for number 10. Everybody get that? All right. Again, here's that complex conjugates for number 11. So we multiplied everything, this time by 2 plus radical 2, 2 plus radical 2, all right? Which means the O and the I are going to zero out, and the F and the L are going to be like terms. That's what that accomplishes for you. The O and the I are going to zero out, right? And the F and the L are going to become like terms. Here it is right here. So you got plus 2 radical 2 and minus 2 radical 2. That's where it zeroed out, right? And we ended up with 4 minus 2 for 2 in the denominator, all right? On the top side, we had 10 plus 6 radical 2, and the 10 and the 6 were both divisible by 2. So there's your final answer, 5 plus 3 radical 2. And then number 12 it was done very similarly to number 11, multiplying both the numerator and denominator by 1 minus 2 radical 3. And this is what your final answer should look like. These bottom two problems, if you see them again, will probably be a bonus. Because if you can do those, then you can do any of this. All right. Questions, comments, concerns? Okay. Here, no questions, comments, or concerns. Okay, so I got to come out of this. Here's the plan. I'm going to put up problem set number 3. I'm not going to put it on Blackboard. We're going to walk through it collectively over the next 20 minutes. That'll prep you for the quiz. The quiz will look like this, but it's going to be pared down by a third. So it'll be like 20 problems. It's going to be like either 12 or 14. I can't remember, maybe 14. So if you see something like, I don't know where that's coming from, or I don't understand that, this is the time to ask. This is we're gonna work out all the bugs. All right. Let's see here. Are we ready? So just if you've got a loose leaf sheet of paper handy, just hand copy these down because I'm not going to even put them on. This is problem set 3. The quiz will look like this. You're going to have very similar problems with values on the radical of a very similar style of this, but the variables and numbers will be slightly different. All right. So, you ready? All right. So 24. You know, what's 24? What are multipliers of 24? Or what is 24 divisible by? It's divisible by 4 times 6. We love 4, right? You can have that little cheat sheet of perfect squares and roots by you. All right. So that comes out from under the radical as a 2, leaving 6 under the radical. You're done. These first couple are very, very simple, and you should most definitely get these right. 75. We've seen that number a multitude of times. That's the same as 3 times 25, right? And we love 25 because that's a perfect square. So handle it the same way as you do number 1. The 25 comes out from under the radical as 5, and 3 stays under the radical. Good so far? All right.
Good.
Okay, number 3. We're doing cube roots, all right? On your little cheat sheet. You should almost have in your head now, hopefully. 2 cubed is 8, right? 3 cubed is 27, right? 4 cubed, you ought to know 2, 3, 4, 5 is 64, right? I'm not going to write the next one because my pen's so messy. 5 cubed is 125. All right. So if I know 2 cubed is 8, 16, 2 times 8 is a nice multiplier of 16. So the 8 comes out from under the radical as 2, and 2 stays underneath the radical. Does that make sense? All right, Aaron, no questions, I assume so. All right, this guy here, the negative's outside the radical, we just let it ride, all right? 48, but we're doing fourth roots. Like, okay, now what do I do? All right, we've talked about this before. All right, 48, nice even number. All right, I'm gonna start doing multiples, multiples of 2. So 48 is the same as 2 times 24, right? Let's see if I can get 4 2s out of this guy. 24 is 2 times 12, right? 12 is 2 times 6. 6 is 2 times 3. Right? So now I've got 1, 2, 3, 4 2s. Perfect. That's what I was looking for. So those 4 2s come out from under the radical as 2, right? Because we're doing fourth roots, and I still got that lone 3 underneath the radical. I can't do anything more to simplify. Again, think in terms of we're simplifying these, we're not solving them. All right. Everybody good so far? Questions? Now's the time to ask because the quiz is going to look similar, very similar to this. So if we're having struggles, now's the time to do it. Okay, number 5. All right, so the 4 is outside the radical. I got 50, right? All right, 50 we know is 2 times 25. We love 25 because it can come out from under the radical as 5. So 5 times 4 now becomes 20, right? I got x to the 5th. Let me put that, the 25 is 5 times 2, right? So or 25 times 2, so we still have 2 under the radical. Now I've got x to the 5th. So that's x squared times x, right? Or it's x squared is another way to look at it. So the x squared, the square root of that is just x squared, right? And I still got x under the radical. Good?
Wait, where'd you get the 20 from?
20. Okay, the 50 is 2 times 25, right? 2 times 25. So the 25 comes out from under the radical as 5, and the 5 times 4 gives us a 20. All right?
I got it.
Makes sense? Okay, 64.
Sir, wait, what is the next to the 20? Is that just like a scribble or is that actually supposed
That's
to be something?
20x squared. Because we got x to the 5th, so we got x squared. Here, I'm going to write it this way. We got x squared times x squared, or x squared times x, right?
Yeah.
The square root of this guy is just x squared, leaving the x under the radical.
Okay.
Make sense?
Yep.
All right. So now we got 64, we got fourth root. So this is kind of like that 48 we just did above it, all right? So I would start taking multiples of 2 out of that 64, and it actually comes out to be, I'm just going to tell you, it's 2 to the 4th times 4. 2 to the 64 equals 2 to the 4th times 4 without writing this. Doing that little pyramid deal. It's 2 times itself 4 times, all right, times 4, right? Okay, so out from under the radical, I can take 2, and then I've still got 4 under the radical. Even though 4 is a perfect square, that's fine, but this whole thing is to the 4th root, not the square root, right? So a to the 4th, this is a real nice one for you. They were really kind to you. Comes out as a, right? So I got a times a times a times a. So that comes out as a, and the same thing for b. So I got 2ab, and then the 4th root of 4. Are we good? Questions? Okay. Number
And
7.
now he's straight.
All right, number 7, we're doing cube roots, so this negative is okay. If it was a square root or a fourth root, you'd write no solution or unsolvable. All right, so we just talked about 8 is 2 cubed, so that comes out as -2. All right, I've got d squared, right? You having fun over to the right? I got d squared, which I can't do anything with because we're doing cube roots, right? Now f to the 5th is the same as f cubed times f squared, right? So I can leave an f squared under the radical, and the f cubed comes out as f. So if your final answer is -2f, and then under the radical is d squared f squared.
Wait. So why did you leave the D2? Like, why didn't you do anything to the D2?
Because that's just d times d in this. Don't always treat this as a square root. We're doing cube roots. So it's d times d. If it had been d times d times d or d cubed, I could have taken a d out from underneath the radical. But I can't take d squared out from underneath the radical with it being a cube root.
Okay.
Just like f to the 5th is f cubed times f squared. So the f squared stays under the radical, and the f cubed comes out from under the radical as f. Does that make sense? All right, so number 8, we're doing square roots. And if you want to write this as a separate radical for the numerator and denominator, that's fine. It may kind of give you, something may jump out at you to make it easier to solve than what it is. So the 25 is a nice perfect square, so it comes out as 5. 36 is a nice perfect square, it comes out as 6. The r squared can come out as r, and then I still got t under the radical. Are we good?
Sure.
No questions? All right, I keep rolling. Let's see. All right. This guy here, we may want to rewrite just to make it a little more logical to solve, is the same as this, right? And that, if back on our previous problem set, we can rewrite that as that, all right? So you can't give me an answer with a radical in the denominator. So how do we fix that? We multiply that denominator by itself. So we're going to actually do this, right? So I'm just going to put the answer down here. So that becomes 7 under the radical, or the square root of 49, which is 7. And then on the top, we end up with negative. Don't forget the negative sign. You'll lose a point if you don't. 3 times 7 is 21. And I can't do anything. I can't simplify 21. No perfect squares back from a radical. Make sense? All right. I'm going to rewrite this just to make sense. Okay, we're doing cube roots, right? And I can't have a radical in the denominator. All right. So, for an extra 3 points on the quiz tomorrow, what do I multiply that guy by to solve?
9, right?
Wrong. Next guess.
1.
Wrong.
Rita.
Next guess. Wrong.
L.
Cone loses 3 points.
Uh,
Square root of 9.
Wrong.
L.
Think. This is a thinking man's game.
Oh, 2.
2. Why would you do 2?
you just said.
I want that 9 to come out from under the radical, and it's a cube root. I gave you a clue at the beginning of the class or beginning of the page.
3.
Who said that? I think it was
Fine.
Bunch. Bunch gets.
Me.
All right, let me explain.
It's 3, sir.
Mr. Bunch, no, why don't Mr. Bunch, you explain?
It's because I just do it in my head because
Yeah.
it's like 9 divided by 3 is 3.
How about 9 times 3 is 27? That's a perfect square. So now I've got 3 in the denominator. All right. And on the top, I've got 3 times 2 is 6. Cube root of 6. We multiplied, Mr. Bunch multiplied by 3 because the 3 times 9 gave us the 27, which gave us a perfect square. All right. So Mr. Bunch has got at least a score of 3 on the quiz tomorrow if he does nothing else. That was, I think. That was a good thinking one. Good question for Jeopardy. All right, let's see what we got to talk about here. Let me start skipping around if I need to, just to make sure I get the high points. All right. I'm not going to do this one because now it should become repetitive. We're just going to multiply number 11. We're going to multiply both of these by 5z. That doesn't look like 5z. But we're going to multiply both by 5z. All right. Which is going to give you 5c in the denominator. All right. What are we going to do in number 12? What's it telling you to do or asking you to do?
Boil.
Well, actually, it's just going to be, it's just this, all we're going to do is multiply, right? So let's see what happens here. 3 times, this is kind of a good thinking one too. 3 times 5 is 15, right? Radical 3 times radical 3 is radical 9, which is a square root of 9, which is 3, or anything under the radical times itself is always itself, right? So our final answer is 45. Everybody see that and see why? Everybody see that and see why? Okay. Now, you can do this just like we did the last one, and you'll be fine as long as there's no careless mistakes. Or we could simplify this. 12 can be, under the radical, can be rewritten. That's the same as 4 times 3, right? So the 4 comes out as a 2, leaving 3 under the radical. Did you see what I did? 20 is 4 times 5, right? So the 4 comes out from the radical as a 2. 2 times 3 is 6, leaving 5 under the radical, right? And then we just multiply the 8 times the 6 is 48. And the 3 times the 5 is 15. So it's 48 radical 15. Now,
You got that, Jay?
he ain't even here.
Crazy.
Nice try though, Eddie. Pretty cover.
Sure.
Or we could multiply 12 times 20, which is 360, right? Is that right? No, 240. So you end up with 12 radical 240, right? And you could then simplify that, which is going to be, let's see here. That's 16. Yeah, I think that's 16 goes into that. 5 times? Yeah. Is that right? 15. I'm just trying to do the mental math. I don't have my calculator. Yeah. Yeah. 240 times 16, right? 15 times 16. So the 16 comes out as 4. 4 times 12 is 48, leaving 15 in the radical. So you could do it this way. The advantage of doing it this way, which may be a little more labor intensive, keeps the numbers smaller and easier to manage. But both ways work. All right. Now, let's look at 14. I want you to try that. All right. and we want to get some like terms or like radical expressions that we can actually add. Take a second, jot it down, and see what you can do with that, and then I'll talk about it. All right. I can't simplify radical 2, can I? But 8 is 4 times 2, so that I can bring the 4 out as a 2, leaving 2 under the radical, which is a good deal. I can now combine those two like terms. Now I'm thinking, what's 50 divisible by? Can 2 go into 50? And it does, and what happens? It's 2 times 25. So the 25 comes out as a 5, leaving 2 under the radical. Now I got 3 like terms, or 3 like radical expressions. So my final answer is going to be 8 radical 2. Does that make sense?
Wait, how?
I'm
'Cause-
sorry?
Wait. How would you get 8? Wouldn't you get 7?
What's in front of this guy?
Oh, I thought it was just blank.
Plus 2 plus 5, 8, right? Does that make sense?
Yes, sir.
Okay.
Oh, fuck me.
All right. I want you guys to do 15. Here's a clue. Here's a clue. You try 15, I'll give you like 90 seconds and then I'll walk you through it. If you get done, I want to try number 16. I've underlined the clue. All right, I hope everybody got 6 radical 3. Because 12 is 2 radical 3, because that's 4 times 3. So the 4 comes out as a 2. Can't simplify negative 2 radical 3. 108 is 36 times 3. 36 times 3, right? So the 36 comes out as a 6. So 2 minus 2, those zero each other out, and I'm left with 6 radical 3. Make sense? Questions, comments? All right, number 16, I underlined a like term that you want to strive for. Hint, hint. So give that one a shot. Have fun.
Of course.
Pete's watching.
Class is always fun with you.
You could be watching The View.
Uh,
The person that's doing.
la, 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 la.
Thanks for watching The View.
He's watching the Lifetime channel.
Cookout at your house.
I'm watching Jerry Springer shit, sir.
Are they fighting yet? Okay. All right, I put the answer to 16 on there. I'm not going to explain it unless you've got a question.
Shit, my mic.
Final
All
answer
good.
hopefully should be radical 5 or the square root of 5.
All good.
Sounds like Mr. Curzon or Mr. Cohn needs some Pepto-Bismol or something. Sounds like he's got stomach pains.
Why, sir?
All right,
Oopie.
everybody good? Everybody good through 16?
Mr. Daniels had to ask you a question. He said, do you have Clash of Clans, sir?
Why can't he speak for himself?
Because there's a burrito in his mouth.
No. All right.
Oh my gosh.
All right, if you want to write this one down, this is done the same way. Your final answer is radical 3.
What's the burrito?
All those can simplify to radical 3 something or other. All right. So that's done the same way. Just simplify each of those 3 components to radical 3. All right, so number 18, what are you being asked to do here? You're asked to FOIL, all right? So we got 2 times 6 is 12, right? We got 2 times negative square root of 2. So now we got minus 2 square root of 2, right? And then we're going to multiply square root of 3 times 6. So now we got plus 6 square root of 3. Excuse me. And then we got square root of 3 times the negative square root of 2, and that's the negative square root of 6. Am I done? Or can I do anything else with that?
No.
Is there something else I can do there?
Mm-mm.
Nope, because those are all 4 of those terms are not, and none of those 4 terms are like terms. I can't consolidate them. All right, 19. What are you being asked to do?
FOIL.
All right. Now, if you want to, I can show you how to cut corners. You don't have to FOIL this. You can do F and L. You can skip the O and the I. Why? Because these are complex conjugates. We got a negative square root of 5 and a positive square root of 5. So your O and your I are going to zero each other out. If you recognize this, all we have to do is F and L. 1 times 1 is 1, right? Negative square root of 5 times the positive square root of 5 is minus 5, all right? Or technically it's minus the square root of 25, which is minus 5. So our final answer is negative 4. You can FOIL it, and like I said, the O and the I are going to cancel or zero each other out. I'm just trying to, if you recognize this, you can save yourself some work. But this is only true when this value and this value are exactly the same with opposite signs. FOIL will always work. I'm just trying to save you some time, okay? You're going to FOIL these guys. If you want to copy it down, you can do that later, all right? This here is a FOIL too, right? So you're really just multiplying the square root of 2 minus the square root of 6 times the square root of 2 minus the square root of 6. Excuse me. All right? This is a 2. This is what you're doing, all right? So let's see what happens here. Square root of 2 times the square root of 2 is 2, right? Square root of 2 times the square root of 6, negative square root of 6, is the minus square root of 12. I got negative square root of 6 times the square root of 2 is another negative square root of 12, right? My O and I are always going to be like terms. I can combine. And then I got, what do I have left? Square root of 6 times the square root of 6. It's 2 negatives, which makes a positive, so it's going to be plus 6. All right, now I'm just going to combine like terms. 2 plus 6 is 8. And it's minus 2 radical 12, because I got two radical 12s there subtracted from each other. 2 radical 12. Everybody see that and where that came from? Questions? You guys are quiet. Are we actually doing algebra? Are we watching?
Sir, we're doing algebra for you.
Are we watching Jerry Springer?
A little bit of both, sir.
Okay.
I'm a multitasker, sir.
Yeah, that's what I heard about you. All right. All right, here we're gonna solve this by complex conjugates. So we're gonna multiply the numerator and the denominator by 7 plus the square root of 2 and 7 plus the square root of 2. Here's where you can cheat a little bit on that denominator. You can, instead of doing FOIL, you can do F and L, right? And then you can go from there. So the quiz is uploaded on Blackboard. I think it's 12 or maybe 14 questions, I think, with 2 bonuses.
Random quiz.
Yeah, it's not random for me. You have to take it by class time on Thursday. If you don't, I'm not going to
Some
take
cheese.
this, okay? Hopefully more than
Cheese.
7 or 8 of you that uploaded 6-5 problem set 2
Hers.
will take the quiz. 'Cause
What?
I'm not going to take any like this. It shouldn't take you more than 25 minutes. If you understood what we just did this problem set 3 and don't have any problems or difficulties, then you should be fine. If you run into a question or problem, I got office hours from 2 to 3 today, or 2 to 2:30 today and 2 to 2:30 tomorrow. You can check in with me then. And that's the plan. Any questions, comments, confusion?
Sir, Suki, let's go past this quiz.
Oh, I already did, Pat. I got 100.
Ugh.
Square.
So you cheated.
Tomorrow.
Have a nice day and cook out at your house this weekend. Don't forget.
The quiz has to be done before class on Thursday. If it's not done by Thursday, it'll be Mr. Cohn's famous 4 words.
All right, sir.
So
Have a
sad.
great day.
Too bad. So sad, sir.
Have a great
Mr.
day,
Bunch,
sir.
Mr. Bunch, how'd you get a haircut? All the barbershops are closed.
Sir, I shaved my head when we got out of school.
Oh,
Yeah.
take a pass on that. I think I'll wait for the haircut.
Yeah.
Barbershop's open. All right. Any other questions, comments, concerns?
No, sir. Have a great day.
All right. Have a good day. 2 days. We'll see you back here on Thursday at 1 p.m. sharp. Take the quiz. Don't get. Bye.
Bye.